Hello everyone, welcome back to another video. Uh, since in the last video I covered some graphs concepts, so I thought that I would make another video on graphs. So today I'm back with another video, and this time I'll be focusing on breadth first search (BFS). So talking about graph traversals, we have two types of graph traversals: breadth first search (BFS) and depth first search (DFS). In this video, we'll be basically covering breadth first search, which follows an iterative approach. In future, I'll also try to make a video on depth first search, which follows a recursive approach. But breadth first search is quite easier to understand, so in this video, we'll focus on that. So let's go. So breadth first search, what we do in breadth first search is that we try to traverse the graph layer-wise. And what does layer-wise mean? Suppose I'm at a source node, which is right here, and first I traverse this node, then I traverse the next layer, which is this one, and then finally I'll traverse the last layer, which is this one. So what does this mean? How can we do this? So let's cover that. So breadth means that we'll cover this breadth-wise. That means we'll traverse the graph breadthwise like this, which means layer-wise, and thus we explore the neighbor nodes. So what does this mean? Okay, so currently suppose I'm in a source node, which is this, and suppose I've traversed this, then I'll go to its neighboring nodes. What are neighboring nodes? Which are directly connected to it. So suppose I mark this as 1 and this is 2. So these two are the neighboring nodes of the source node. So after the traversal of the source node is completed, the next traversal would be of the nodes number 1 and 2. And that's what I've also written, that the nodes which are directly connected to the source node. And what does first mean here? That we first start with the node, we traverse it, and then search for the neighboring nodes, which is the right next node, which is directly connected to it. And then we search again breadthwise and do layer-wise searching again. So suppose I'm given a graph which is in form of an adjacency list. What's an adjacency list? Every node of a graph, suppose 0, here is 0, here is 1, here is 1, here's 2, here's 2. So all the nodes of graph have a particular list attached to it. That list denotes the nodes which are directly connected to it, or the nodes which are neighbor to it. For suppose this is node number 0, then the node which are neighbors to it are 1 and 2. Suppose we have node number 1. Nodes which are neighbor to it or which are directly connected to it are 0 or 3. 2 is not the neighbor of it because it's not directly connected to it. So similarly, you can see we have so many nodes, and for each node we have a particular list attached to it, which signifies the adjacency list. So how will we do the traversal? First, we'll start from node number 0, which would be our source node. We can start from any node. We could start from node number 3. We could start from node number 1. But to keep things simple, I thought that I would take 0 as source node. Then we'll, in the next step, try to visit the neighbors of 0, that are 1 and 2, and do breadth-wise searching. And after this, we'll go to the next neighbor, which is 3. In the next step, we will go to the next neighbors, which are 4 and 6. And finally, our final node would be also covered, and that means our traversal is complete. And we can stop here. So now you know that we start from a node and we need to go level wise. And once we go level wise, you see that we first explore the source node, which is node number 0. And after exploring node number 0, we know that it has two child, 1 and 2. Now, if you are standing at the start of root node, you want to go its neighbors. And in adjacency list of 0, as you can see, this was the adjacency list. We have 1 and 2 as its neighbors. We want to go to both of them. Now, how is it possible? So, for visiting them both simultaneously, we might need a data structure. That's how we could explore it. Now, think of it, which data structure can be used. So, since this is kind of a sequential form of traversal, so a queue might be a very good option for maintaining our uh, nodes which are neighbors of the current node, and that might help. And also, So suppose we traverse to the node number 0 and we have 1 and 2 in our queue. Now after this, uh, we want to explore the neighbors of 1 and 2, which are 0 and 3. Because of breadth first search, we only need to go to the next layer, which is of layer number 3 or node number 3. But 0 is also the neighbor of 1 and 2. So how could we avoid traversing 0 again? We don't want to complicate our traversal. We don't need to uh, uh, increase the number of steps required to traverse the entire graph. For that, we might need to maintain a track data structure, which basically keeps track of all the things which are already visited or all the nodes which are already visited. For that, we might make a visited array like this, which would keep track of all the arrays or of all the nodes which are already visited. So, in order, we require about two data structures, which are one queue, which keeps track of all the neighbors of the current node, which are going to be visited, and we require one visited array, which keeps track of all the nodes which have already been visited, so that we don't visit them again. Now, after this, we could look at the code of this problem. So, let's dry run for this. So, suppose currently we are at Q. We made the source 0. So, 0 would be entered in our queue with the help of this. So, a queue would be made from here. And because of this line, 0 would be pushed to our queue. Since 0 is pushed, and since our queue is not empty, by the way, visited would also be marked as 1. That means our 0 number node has already been visited once. Okay. And after it, we require the front node of the entire queue, which is this 0. We would pop it from the stack, or we would pop it from the queue. And after popping it, we would require the child of this current. That means the node number 0. And its children are, as you can see from the figure, are 1 and 2. So these two would be because of this, because it has already been visited. If the current node is already visited, since you can see that it has been visited, then we will push the children of it into the queue, and its children are 1 and 2. And this will be popped out of the stack, and all the children would be marked as 1. So we would mark our node number 1 as 1 and node number 2 also as 1. And like that, we would traverse all the nodes. So suppose now this would be pushed out of the queue, node number 1. If we start the loop once more, then our current node would be 1, and 1 has a child 3 and 0, since 0 has already been visited once. So in the next step, only 3 would be pushed to the stack, or 3 would be pushed to the queue. Why am I saying stack all the time? I don't know. So yeah, 3 would be pushed here, and 1 would be popped out from the queue, and 3 would be marked as visited. After that, what we need to do? Now we need to check the children of 3. Since 2's child is only 3, which has already been visited, so it would be pushed out of the queue, and 3 would be explored. The children of 3 are, since 3 is already been traversed, we would also uh, mark it as checked. Now its children are 4 and 6, which would be pushed to the queue. 4, 6, and 3 would be popped out of the queue, and also the visited would be marked as 1 here. I'm sorry, this would be 1, and this would also be 1, which is the node number 5. Sorry, node number 6. And now the child of 4 would be explored. in the queue, and node number 5 would be visited, and here we would mark it as visited. This would be cancelled, this would be popped out, and since our queue is now empty, so and finally 5 would be pushed and it would be popped out because it has no children, and since our queue has been empty, and it would have been worked if only it had something. So our traversal is completed, and that marks the end of the breadth first search for this particular graph. So I hope you understood the code and the problem. If you didn't understand anything or you didn't like the video, please uh, throw your suggestions in the comments, and please hit that big red subscribe button if you like this content. I would be continuing the series on graphs. Uh, and the next video would be out very soon. If you require any other help, you can definitely write down in the comments. Thank you so much for watching.